This video is going to talk about parabolas. It's going to also talk about relationship with quadratic functions. We'll be talking about how to draw parabolas. We'll be talking about the turning points of a parabola. We'll also be talking about different facets like the domain, the range, and other parts that you need to remember when answering questions regarding parabola and quadratic functions. I hope you guys like it. A quadratic function has three formats. The first format is the standard form, which we see in 60 to 70% of questions. It looks like this, which is ax squared plus bx plus c. The second format that we do have is the turning point format. And the turning point formula looks like this, which is a open bracket x minus p squared plus q. The p and q represents the coordinate of your turning point. The last format in which we also have is the x-intercept format, which looks like this. And in the x-intercepts, the formula is a open bracket x minus x1 close the bracket x minus x2. The x1 and the x2 represents your x-intercepts. The question in which you're given tells you which format to use. What I mean by that is if you're given a question that has x-intercepts, you use the x-intercept form. It's as easy as that. If you're given a question that has turning point, you'll use the turning point form. Yeah, that's what you always need to put at the back of your mind when answering questions regarding parabolas. One thing that every single equation has is that it has an A. For each format, either the turning point, the standard, or the x-intercept, they all have an A that starts your equation with. And this A tells you if your graph is going to be this or that. Now, the first one we have over here, the A is positive, while the second one we have over here, the A is negative. So both shapes has a turning point. For one of the shape, it has a maximum point, which relates to the turning point. And while the other shape has a minimum point, which also relates to the turning point. And what all this means is this. So our turning point is divided into two. We have the x coordinate and the y coordinate. For the x coordinate of our turning point, it is your axis of symmetry, which means a line that divides your graph into two equal parts. So if you divide your graph through it, you will see that that is your axis of symmetry. So talking about the y coordinate represents the highest possible point in which your graph could get or the lowest possible point in which your graph could reach. And those are your minimum and your maximum value. Now they relate to the shape, and those are the things you need to remember about your turning point. The axis of symmetry, which can also be called the line of symmetry, and your maximum and minimum. So let's talk about sketching. If you want to sketch your parabola, you will need your x-intercept, your y-intercept, and your turning point. Now, to be able to sketch this function over here, which says y is equals to negative x squared minus 2x plus 3, we need to find our x-intercept, our y-intercept, and our turning point. So let's start with getting the x-intercept. To get the x-intercept, we make y equals to 0. So it will look like this, 0. Then we factorize. Negative 3 and 0, and 1 and 0. Then next we get our y-intercept. We substitute x as 0. So our y-intercept is 0 and 3. So finally we'll get the turning point. Now turning point has an x coordinate and a y coordinate. So we need to get the x coordinate first. After we get that, we substitute the x coordinate back into the original equation to get the y coordinate. Now to get our x coordinate, the formula for the x coordinate of our turning point is this. Right? So therefore our answer would be 1 and 4. So now these are the 4 coordinates we're going to play around with. So we have our x-intercepts, our y-intercept, and our turning point. We're going to use every single one of this to draw our graphs. So our necessary points on our graph, all we just need to do is connect the curve. Now, I'm a horrible drawer, so bear with me if the curve doesn't come out so nice. So try as much as possible to make it a continuous curve, and this is more or less how your graph is going to look. There's one thing I didn't say before, which I should have said. Whenever you see your equation, if the a is negative or positive, try as much as possible to just draw like a small diagram to tell you how your graph should look. Now, as we can see here, a is negative. So the first thing that should have been done was me doing this, saying that, okay, I know my graph needs to look like this. So if after I connect my point and my graph doesn't look like this, it means I'm definitely wrong. If it is positive, my graph needs to look like this. After I connect all my points, if my graph doesn't look like this, then it means I'm wrong. And that's it for this example. So now we'll talk about how to determine the equation of a quadratic functions. There are 2 ways in which you determine the equation of a quadratic functions, and they are based on the format we talked about earlier in the video. This example will be explaining what to do if we want the x-intercept form or the turning point form. Now, both of these ways could lead into your standard form. I will explain it in this example. So, this graph here says we should find the equation. So we're given a couple of points. We see our x-intercept being -1 and 3. We see our y-intercept here being -3. And we also see our turning point over here is 1 and -4. Now those are the points we're given. To find the equation, we can calculate it in 2 different ways. And I'm going to talk about both ways. So the first way we can calculate this by using the turning point format. Now the turning point format looks like this, where we said P and Q represents the x and y coordinate of our turning points. So I will just start with substituting those ones over there. Now you need to take note that original equation, this is a negative. So when I write this, that negative has to be taken into account. So this is what I got by substituting my turning point. The next step I'm going to do is substitute one other point. It doesn't matter, but it mustn't be the turning point. Substitute any other point you like into this. So let's say I take my y-intercept, I substitute my y-intercept. The reason why I'm doing this is for me to be able to find out what my a is. So as you can see here, my a is equals to 1. I put it back in. I could leave my answers like this and I'll be absolutely right. But you could get questions in which they want you to leave it in the standard format. So to change my turning point form to my standard format, all I need to do is expand, open out the brackets. And as you can see, this will be my final answer, right? And this is how we can find the equation using the turning point format. Okay? To recap, the only thing I did was this. I substituted my turning point, then substituted one other point for me to be able to get my A. After doing that, put it back into the turning point formula, I have my final answer. If I need to continue, I could expand it out and it allows it to look like its standard form. That's it. So now I'm going to talk about the second part, how else I can get this without using the turning point form. So the other form we could use is the x-intercept form, which we said looks like this, where the x1 and x2 represents x-intercepts. So what I'm going to do here is substitute those. So that is our x-intercept form. Now, we would also need to get our a by substituting any other point apart from the ones we've used. So again, I'm also going to substitute the y-intercept. Why? Because I can. So now this would be our final answer if we need to stop here. However, if you want to take it a little bit of a step further by getting the standard form, all we need to do is expand. So we're just going to open the bracket. And that will give you, and that's your final answer. That's exactly how they wanted you to answer questions like this involving equations. So we have two choices. We either could have used the turning point, or we could have used the x-intercept. Whichever case we choose, we can take both of them to the standard form by expanding. That's all. So the last point I want to talk about in parabolas is about domain and range. Now, the domain and the range of any function refers to all the possible x values and all the possible y values of the particular function. But specifically to parabolas, your domain is usually all the possible x values, literally. So it's x is an element of real numbers, right? And we could write it in this format over here. However, for the range, we normally say it is from your y coordinate of your turning point, which is your maximum or your minimum point, to infinity. And that's it. This is the basic info on parabola functions. We have other videos on functions in the playlist in the description below. And on your way out, please don't forget to like and subscribe. And that's it from me. Bye.